Hello, in this video we're going to go through a couple of examples of given an equation and a point. Can we write an equation that is both parallel and perpendicular to that? So currently on the screen we have the equation y equals negative 4x plus 6, and we are asked to write an equation that goes through the point 8 comma negative 3 and is going to be parallel to our given line and perpendicular. So before we get started, the first thing we want to do is we want to identify what our original slope is. So that number in front of our x is negative 4. So I would write down, hey, my original slope is negative 4. For a parallel line, which is what we'll do first, the slopes are the same. This is what ensures that your lines never cross. They're rising and running at the same rate. And because I am given a slope, negative 4, and a point, 8 comma negative 3, it is going to be easier for me to write this equation in point slope form. I already have everything I need. I don't have to do extra work to write a different equation like I would with a slope intercept. So as a reminder, the equation for point slope is y minus y1 is equal to m times the quantity x minus x1, where y1 and x1 are the coordinates of the point that we're given. So if I'm writing a parallel equation, I know my slope is going to be negative 4, and then the point that I am going to use is the one my problem wants me to. So I'm going to use this point 8, negative 3. So when I am writing my equation of point slope, the sign of the numbers in the point to the equation change. What this means is I have the x coordinate of positive 8. I am going to write negative 8. In my point, I have the y coordinate of negative 3. So I'm going to write the y in my equation as positive 3. And now I have the equation of a line going through a given point that is parallel to my original line. This y plus 3 is equal to negative 4 times the quantity x minus 8. That is our equation that goes through our given point and is parallel. Now, if I were to do this for a perpendicular line, the only difference is going to be my slope. For a perpendicular slope, remember we flipped the sign, so that was negative, now it's going to be positive. And so I also flip the fraction because this is an opposite reciprocal. So the reciprocal of 4 is 1 over 4. And remember, this 4, even when we're graphing it, we rewrite as negative 4 over 1. So when I flip it, it becomes 1/4. And everything is going to stay the same. That point doesn't change in this problem. My slope will be a different number. But otherwise, the equation of a line that goes through the point 8 comma negative 3 and is perpendicular to our original equation is going to be y plus 3 is equal to 1/4 times the quantity x plus 8. I have one more example that I'd like to go through. And all I'm doing is going from a whole number slope to a fractional slope. The idea is going to be the same. I identify my slope. I do, for a perpendicular line, I find the opposite reciprocal. And then I'm plugging the coordinate points in the slope into the point slope equation. Could I do this for slope intercept? Yes. However, to find my y-intercept, there'd be extra work there, and we just don't want to do that. So just like before, I identify my slope. This time it's 2/5. Okay, just like before. The equation of the line I'm going to use is point slope. And now I'm just going to plug stuff in. I'm going to plug in 2/5 for my slope. And as I write my coordinate points, I'm changing the sign. So the x coordinate in my point is -6. So right next to x, I'm going to write +6. My y coordinate is -3. So now I'm going to write +3. And here's another equation that is parallel to my original line that goes through our given point. The last one, again, the only difference is going to be it's the opposite reciprocal. The opposite reciprocal of +2/5 is -5/2. Otherwise, everything stays the same. And there's our perpendicular equation. So here's a couple of examples of being given an equation and writing the equation of a new line that is parallel and perpendicular through a given point. Please reach out if you have any questions.